everyone. Great topic to start the BPI series in 2022. So today I will be strongly connected to learn more about modern methods of building super insulated timber frame homes.
Yeah, so huge thanks to everyone for joining us today for what is a project and a system that I guess it aligns perfectly with Passive House, really strong focus on breathability and low energy construction. So yeah, interested to see what everyone thinks.
Hi, I'm Ben Adam Smith from House Planning Help. And yeah, I know this system quite well, having seen Lee down at the National Self-Build and Renovation Centre, and he's always answering questions when people come up and want to know about how to build a low energy home that also has low embodied carbon. And I think one of the things that I really like about this is that it's almost, you can't go wrong when you have this sort of approach. It works for Passive House. So I'm looking forward to learning and hearing more about it.
Hi, Mike Jacob, Kiss House. It's really nice to be co-hosting this episode today. MBC are quite close to my heart. I've delivered several projects using their system. And yeah, I know intimately how much they care about getting things right. And I know a lot about the thought and care and goes into detailing their system and delivering their system to a very high standard. So it's a real pleasure to introduce the guys today. I'll kick off by introducing Adrian first. Adrian Williamson is the Director of WM Design and Architecture. Adrian's a Chartered Architectural Technologist, and his practice is based in the beautiful Anglesey, just off the coast of North Wales. Adrian's been working in the design and built environment for 35 years, with his first job being as a model maker for the Ministry of Agriculture, Fisheries and Food. And then on to working in the primary healthcare field as an architectural designer and technologist, and set up his practice in 2003. Their principal field is in modern architectural design and construction, and we look forward to hearing Adrian soon. And then also it gives me great pleasure to introduce Lee Broomhall, sales manager of MBC Timber Frame. Lee's been involved in technical sales based on a consultative approach for 15 years, specializing in timber frame and sustainable products to the bespoke self-build market. And for the last 5 years, Lee's focused specifically on passive house build systems and is dedicated to educating people that modern off-site construction methods are accessible to all to build more sustainable and durable houses. Thank you very much. Over to you guys.
Hi, my name is Adrian Williamson, and given an intro earlier on, we're a practice based in Anglesey in North Wales, and we were housed in this beautiful building. It's a technology centre in the middle of the island, and that's where we sort of principally work from. Anglesey, Gwynedd and Snowdonia is our sort of kind of field, and mainly doing sort of residential extensions, adaptations, but a lot of kind of new build, self-build, that sort of thing, really. So we were approached about 2018 about a site in a lovely place called Red Wharf Bay. For any sort of people who kind of know the history, it's where the Land Rover was first tested and practiced on this area of beach here. So it's got this little bit of claim to fame. The site itself was a replacement dwelling. So this tiny little shanty shack, built kind of timber frame, early construction, but using a very nice asbestos product, which was quite popular in the 1940s and 50s. So the client bought this site and wanted to kind of develop it for a house, but it's right in the middle of the area of outstanding natural beauty. It's tucked into the kind of hillside, and the kind of the views from the site are sort of across the bay here. So we had quite a long process of gaining planning before we even started considering the construction form. So it sort of sits where you can see this little red line tucked in a load of other houses. So the site itself, as I say, is orientated principally sort of kind of in an easterly direction. So it gets the kind of sun up in the morning, gets mid-afternoon sun, but as you can see from the diagram, it disappears around the other side of the house and the back of this kind of caravan site. So views are the main thing that the client wanted here, but equally a really high performing house. They'd lived in timber frame houses before and sort of novel kind of builds before, but they really were moving towards a passive construction. So we had this sort of kind of duality of looking at building in the views here, but also building in a high kind of insulated value and a kind of low energy approach to the actual building itself. So it's kind of, you can see it's sort of tucked in right in the middle of this big sort of Red Wharf Bay here, but the views are over this kind of hillside and out to sea here. So it's kind of set in this kind of the settlement here. So once we sort of got the kind of form right, we could start then exploring kind of views and how we sort of work the building itself. And it ended up with a very sort of U-shaped form, sort of taking in the views, sort of lounge and sort of living space and so forth, and bedrooms on the first floor. So this is the actual sort of composite image that we had to do to persuade planning at the time, because it actually got rejected from planning, and then we had to appeal, and it was all to do with whether it would sort of stand out in the sort of the landscape in a sense, really. But as you can see, there's a whole range of different sort of dwellings and different forms. But again, as you can see from the image, we were trying to take in as much of that view and that kind of glazing as possible, but that sort of leads to, you know, potential for overheating and all the other kind of worries that we have with high efficiency houses. So the actual kind of built form itself is a sort of semi kind of U shape. So we've got a kind of main living space here, tucked away with sort of plant, kitchen, utility at the back, a garage and here, but also like a sort of a sheltered kind of courtyard area with a linking form there, because there is a sort of road that runs down the front here, and they didn't really particularly want people looking in, even though they're having vast amounts of glazing. It's a sort of kind of a balance you've got to find, really. And on the first floor, we've got two main bedroom spaces, each with a green roof, sort of a coastal planting type roof that they can look out of and then over the actual kind of bay itself. So again, all the principal windows were on this sort of easterly facing, southeasterly facing elevation. It's principally clad in a zinc standing seam and then sort of render board on the outside of the actual the passive frame construction. This sort of kind of the kind of final kind of imagery, how it's going to look. We spoke very early on with MBC about sort of passive frame construction, and we were going all the way down getting certified, but as with a lot of clients, sometimes at the last minute they sort of go, "Ooh, not too sure about that." So we're going as far as we possibly can without actually going full sort of passive house design. So it's got MVHR in there, it's got sort of kind of low energy heating system in there as well, high performing windows, and obviously the construction air tightness. So that's the sort of kind of imaging how it's looking. Construction wise, we're aiming to be finished late summer, possibly a little bit later on. But obviously COVID has affected many deliveries of different things throughout the last year and this coming year, but it's carried on site very well, given some of the restrictions we've had. And you can see from some of these aerial shots, and you'll see from a later video how it's moving along. There we go.
Good afternoon, my name is Lee Broomhall. I work for MBC Timber Frame. On this particular project, we've supplied the Passive House standard timber frame and also the Passive House foundation system.
Good afternoon, I'm Adrian Williamson from WM Design and Architecture Limited, based here in Anglesey. We're the lead designers and architectural technologists on this Passive House project here in Red Wharf Bay. The actual sort of build itself is around about the 250 square metres. It's actually only a 3-bedroom house, so it's not the most massive house that we've sort of had to do. But the challenges of the site is that as it was a replacement dwelling and on a very popular seaside beach frontage area, delivery of materials and just getting sort of the equipment in, vehicles, was very, very challenging. And we also were doing the build at the tail end of last year, and up to the Christmas period where we had some pretty horrific weather. So it was pretty challenging for the build team, both doing the slab, the passive slab system, and also the actual frame erection, which is the MBC sort of passive frame system. So we're aiming for a passive standard, not going for full certification, but certainly is meeting the high air tightness standards that are required. The principal views from all of the kind of first floor and the sort of lounge area is across Red Wolf Bay, which is a very kind of famous part of the island. So it takes in a view right from Bwrdd Rafter, right across to Pentraeth Forest and right into the heart of sort of Pentraeth Beach. So they've got a full sort of kind of 270-degree view of the bay from the kind of main kind of master bedroom, the guest bedroom, but also the lounge. And we've introduced a lot of kind of roof terracing that includes sort of a set of sedum planting, sort of coastal planting, so that they feel even at first floor that they're actually part of the landscape. And the view is framed by two TPO'd sycamore trees that we're keeping. So it's sort of keeping a kind of a nice kind of feel of the landscape right in front of you. The reason we chose timber frame is that, again, it was a difficult site to access for kind of materials. So we wanted something that would be fairly speedily built because of the access restrictions. We'd also worked on a previous passive frame project with MBC, and the client's aspirations were for kind of super low energy. So certainly this was a good kind of mix of getting this kind of speed of build, but also meeting the energy criteria that they were looking for. So this is partly the reason we sort of went down that route. In terms of the design, it was already sort of in plans to be some sort of kind of timber frame, not necessarily passive, but certainly after working with MBC previously, it was kind of an easy sort of job to kind of convert or change our kind of drawing specs over to the MBC passive frame. This is actually the second project that we worked with MBC on. The first project was actually a social housing project. So they were kind of relatively simple plan form buildings, so nothing overly complex compared to this, which is challenge of getting a mix of kind of views, orientation, the sort of, you know, wanting a certain amount of kind of spectacular kind of look about the thing from the client's point of view. So it was very much a kind of an iterative process in the design, and then working with MBC to make sure that we could achieve what we were wanting to do using a passive frame system. So certainly it was a collaborative effort to get the kind of design to where it needed to be, and up to the kind of high standards that we were looking for, and also the client's aspirations.
So once we've been appointed for a project, the very first thing that we do is what we call a pre-design meeting. And that's where we sit down with the client and the architect and actually go through the project from start to finish, and just making sure that the designs that have been put through for planning actually work from a timber frame point of view, and explain any sort of structural things that need to be overcome. We then send the drawings to our engineer, and then we get all the engineering and structural calculations completed, at which point it gets assigned to an in-house MBC designer. We then design the timber frame around the architectural drawings, and then provide them to the client for sign-off. Once they've been signed off, that's really when we're ready to go to manufacture. As we specialise in bespoke homes, so every one of the houses that we built is completely different, and this is no exception. The key thing for us is that we've got an in-house design team, so a lot of these obstacles that we come across in every project, we can sort of deal with in-house, and we're not reliant on other people. The key issues with this particular project is the roof. It's not the most simple roof, but one spectacular once you've got over a lot of them complications. And that timber frame can work to any designs, and the key thing is its versatility. With this particular project, there's a lot of things that the client was interested in terms of sustainability and building a really good thermal envelope, but also in terms of access. You know, we're right on the beach, so the fact that we can build a house very, very quickly, that just means that we're not being, getting in the way of the local community, and just getting the house built as quickly as possible. Well, I think the key thing with Passive House, and maybe the reason why there's not that many people do it, is in terms of air tightness. There's no magic material that you can buy to pass an air test. It's purely down to quality of workmanship on site. Now, on Passive House projects and all of our standard timber frame projects as well, we take responsibility for air tightness. So once the client has installed their windows, we have a return visit to site, and that's when we do all the taping and sealing, and then someone comes in and tests the building. The requirement for a Passive House is 0.6 air changes per hour, so that's what will be achieved here. Once the windows have been in, the roof's been finished, that's when we'll come back and do them works. So this project uses our Passive House standard twin wall system. The key thing with a twin wall system, instead of a single stud, you have two studs. Imagine a ladder going down the wall. It means that when the insulation actually gets blown in on site, it can be continuous without cold bridges. So whilst this site and these panels are all made in a factory, and the house comes together very, very quickly, there's actually no insulation on it when we put the panels into place. It means that when we actually put the insulation in, when we're on site, then we can stop cold bridges around corners, the insulation flows around, and also when you get from the wall to the roof, the insulation is continuous. Obviously really important parts of Passive House principles. In terms of the materials used, so on the outside here we can see our Air Tightness board. Now we favour an Air Tightness board just because it's much more durable. So we're going to take responsibility for the air tightness of this house. The biggest concern for us is that the follow-on trades then might be some sort of detriment to the air tightness. So by going for a board, it just means it's much more durable. Now, in terms of the actual wall insulation, we use a material called cellulose. So it's actually made from recycled newspapers. So as well as being a really good U value and a really good thermal insulant, it's actually just a very good green sustainable material. The wall U value here, which is a 300mm twin wall, will be 0.12. Now we can make that wall any size. Sometimes we'll go to 400, 350. It's just dictated by the PHPP and the U values that are required for the particular project. When we go up into the roof, similar, so the cellulose continues into the roof, but we go to a 400.1 U value roof. The key thing when it comes to timber frame is that all your thinking's got to be done early, and the idea is that once you actually go to manufacture, the next bit should be very, very smooth because of all the work that's been done in the design office. Now, typically a set of drawings takes us around about 2 months to get to the stage which we call client approval, where it's ready to be signed off. Now, because we'd worked with this architectural technologist before, that process was a bit smoother because the drawings, a lot of things that we would need to think of had already been thought of. Once the drawings have been signed off, then we're ready for manufacture. The lead time then to get to site is around about 8 weeks. So sign off for drawings to arrival on site is 8 weeks, and that in this case was with the foundation because this particular project was our foundation and timber frame system. Once we're on site, the foundation would usually take about 10 days. We had a few delays on this particular site because of the weather. There's certain situations where you can't pour concrete, and also the wind exposure on this site was very, very bad at times, where you just can't work with a crane. But yeah, generally the foundation was about 2 weeks, and the timber frame would usually be about 2 weeks, but a little bit longer in this example due to weather circumstances. So one of the things that's actually pretty unique to MBC is that we're a timber frame supplier that also installs foundations, and there's a number of reasons for that. One of which is that the junction between the timber frame and the foundation, when you're talking about Passive House, is really, really tricky, and it gives us a bit more control to make sure that the insulation that's in the wall is actually sitting on the insulation that's in the foundation. Now, in terms of the foundation, we're talking about 300mm of insulation because it's a raft foundation, so the insulation actually goes below the concrete itself. It just makes it a lot easier to integrate the timber frame to the foundation, and then we've got layers like here with the DPM and the radon membrane. But it also means it uses a lot less concrete because of the way that a raft foundation works. So there's lots of benefits to using a raft foundation, particularly when you're talking about Passive House. The U value on our insulated raft foundation is 0.1. So by using a breathable board on the outside, it means that if moisture ever gets into the building, it can essentially escape. It also reduces the moisture content by around 5%. Obviously, as well as that, it just means that we're increasing the longevity of the building, and sometimes by using these additional products, they might cost a little bit more money, but they're just increasing the lifespan of the building. Well, the key thing with the EcoFoil is it has a low emissivity, and it also means that because of a lacquer that's on the foil, it protects against salt in the air, obviously really important in this location. Brilliant, that's over to me now. First of all, I just wanted to say thank you for the invitation today. It's these events are great. It's a real privilege to have been asked to come on and talk. So thank you very much for that. My name is Lee Broomhall. I work for MBC Timber Frame, as you saw there. We supplied the timber frame and the foundation for this particular project. I just wanted to take a minute just to talk about the system in a bit more detail, and really why MBC is probably a little bit different to a lot of the companies that you might be aware of. The key thing with MBC is that we specialize in the entire thermal envelope. Generally, you've got a company that might do a roof or a wall or a foundation. And when it comes to Passive House, they're typically quite easy to do. The difficulty is how you get one to talk to the other. So on most of our projects, and certainly our Passive House projects, we do the foundation and we do the wall and we do the roof. So that means we can do the entire thermal envelope and make sure all the insulation is connected. And it also means that we can take responsibility for air tightness, which in my view is probably the hardest thing to get someone to take responsibility for on a Passive House project. So just to start at the ground up, so the foundation. So our foundation is a raft foundation. We favour a raft foundation because it's insulated below.
Generally requires less digging, less concrete. So it's it's one of the greener types of foundations materially. And because it's insulated below, it just makes it easier for us to actually sort of take control of that timber frame to the foundation junction. So just to see that in a bit more detail here. So this shows our timber frame, which is a twin wall system, as I mentioned on the video. So you can see there them ladders that I was referring to that go down the wall. So how we pump the insulation in, it flows between them ladders and creates this continuously insulated timber frame. Now the really clever bit here is that the insulation, which is the yellow bit in the timber frame, is actually sitting on the insulation, which is the red and white bit in the foundation. That's the first part of our continuously insulated shell, and really one of the most difficult junctions to get over on a passive house. So you can see on the picture, so that's the inside board I was referring to on the video. So it's an airtight board, and again we use it just because we're really trying to not just pass an air test, we're trying to maintain an air test. So once we leave site, we want to make sure that air test is maintained. So as well as fitting the air tightness board, what we'll always do is also fix the service battens. And that means that once we've left site, the follow-on trades have always got something to fix to without going anywhere near that air tightness layer. So we're just trying to do the best that we can to make sure that the air tightness layer is maintained. There's a lot of trades, particularly in the UK, that might not have worked in an airtight building before. So we try and encourage people to make sure that any trades coming onto the site are aware it's an airtight building, but also just do what we can to make sure the building is protected as best as possible. On the outside, we use a board called Medite vent, and we've got our foil, and that means it's a breathable board. So if moisture ever does get into the wall, it means that that it can escape and the building can kind of repair itself. So not the best picture, but moving up to the roof, we've got a few different ways of doing the roof. So this is showing a metal web rafter. You've probably seen metal web joists before in a mid-floor. Sometimes we'll use them in the roof, and they're really good. If you can think of it the way that the wall works, the twin wall, you kind of end up with this like twin roof, so the insulation can flow between rafters. So not always with a metal web, we've also got I-beams, or we can use timber, depending on particular projects and what the preferences are of the client. But it's all about just trying to keep that continuously insulated shell. And again, as I mentioned in the video, so once the insulation gets up to the eaves, the insulation then continues into the roof. So that's a very, very tricky junction, to get over, to make sure that we're continuously insulated. And often what you see on various passive house projects is you see like a hybrid of different systems, and individually they can all be fantastic. The difficulty is getting them all to work together. So this is the way that we do it, just try and keep a bit of consistency around the building, and making sure that one person is taking responsibility. If ever does go wrong, you've only got one person to blame. And here you can see the whole system. So I mentioned the metal web joists. So you can see in the mid floor there that we've got our metal web joists, and it's top hanging on the inner stud. And that's really important, because what it means is that we can still get insulation straight past that stud up into the first floor. So notoriously high risk cold bridging area on most homes is that detail there, because typically you just sit your joists on your ground floor, and it's somewhere where it becomes very, very difficult to get insulation. So by doing it this way, it just means we've overcome one of them really sort of tricky details, especially when you're talking about passive houses. So you can see the U values we've got here. So 0.12 in the wall, 0.1 in the roof, and up to 0.1 in the foundation. That can vary dependent on how much steel needs to go in the concrete. But we can make all these any bigger or smaller as they need to be. So obviously, if it's the perfect passive house project, then you can get away with a little bit more in terms of U values. But we'll often make the walls probably the most common, where we might go to a 400 mm wall if the PHPP just needs a little bit of a better U value to that area. We have our own in-house design teams. Again, a lot of companies will outsource the design. We try and keep as much as we can in-house, because it just gives us more control. A lot of our designers are actually Passive House certified, and it means that when we're designing the timber frame, we're not just thinking about structurally how the building is going to work. We're thinking about from an insulation point of view, how can we make sure the fabric is as good as it possibly can be. Now, also the designers are upstairs in our factory, so if there's ever something which is a bit tricky, they can go and speak to the factory manager and go and actually I've just got a bit of background noise there. I'm sure if someone can mute. But they can literally actually go and speak to the guys in the factory, as you can see here. So our factory is It's very modern. So what we're seeing in the UK is a lot more sort of passive house companies popping up, but there's an awful lot of people doing it stick build, where they'll make it loose on site, and they'll still do, they'll just take longer. There's not that many people that are actually doing it in the UK with a factory, and that's because of the sheer cost it takes to create a factory, especially a factory that can knock out passive houses. So we've got a lot of machinery. So we've got CNC machines and all these different things, and it means that as well as making a house very, very fast, we can also do it very, very accurately. So we're trying to minimize our tolerances as much as we can, so that it goes together so much quicker and easier on site. Just going to quickly show a time lapse of the project that we've been referring to today on Anglesey. So we're starting with the foundation. So we're looking at getting to a flat site. Generally, the client will get the site prepared for us, ready to arrive. And the first thing we do is we put down hardcore. Now, depending on how tricky the site is in terms of soil quality and trees, that depends how much hardcore we put down. If it's really good soil, you're looking at about 150 mil of hardcore. And then you have some sand binding, and then you put your insulation down. So you can see the outside of the insulation is like an L shape, and that's because we're trying to create this bowl to pour our concrete raft into. DPM radon barrier goes down, and then you put your steel. So for people that are having underfloor heating, we would actually fix the underfloor heating pipe at this stage and fix it to the steel, and actually encase the underfloor heating inside the concrete itself. And then we pour the concrete, and it's power floated to a really good finish. We then leave the concrete is time to dry, and the scaffolding goes up, and we put our sole plates down, which is how you connect the timber frame to the concrete raft. On most of our projects, we arrive with a large lorry, and we use a crane to put the panels into place. So these, you can see the sort of size of the panels we're talking about. It goes together very, very quickly. Craning them all into place and then fixing it really doesn't take a lot of time. So when you're talking about walls, it's a very, very quick process to get from nothing to something very, very fast. The mid floors as well are generally pretty quick in terms of putting your metal web joists in. And then also the walls upstairs are pretty quick as well. Where you generally have the most time and also expense and complexity is in the roof. Walls, floors generally relatively easy. It's always the roof where you're going to run into any difficulty and where you might take a little bit longer than you planned here, because generally you're dealing at angles. It doesn't typically come in panels. It comes loose because you can't really achieve these angles with panels. So we try and leave the building. So you see they're putting the felts and batten on the top there because we want to leave the building dry, so that it's ready for the windows to be installed by the client. So showing that now in terms of how we've left it. So you can see there how we've got the we felt and batten the roof, and that house is now ready to have the roof finished, and then for the windows to be installed. And once that's happened, we then return with our Air Tightness team, and that's when we seal the building. So we come back, we do all the taping, all the sealing, and then for a third party to come and actually test it. And assuming we pass our 0.6, then that's our job, our work's completed. I think this is a particularly nice project for the guys to work on. A really nice place to put up a timber frame. So I said I've been Lee. Obviously sticking around for the Q&A if people have got any questions. I'll answer them as best I can. If there's anything that I can't get you, you have our email address there. Send me an email and I'll be able to get a response from our technical team later. But thank you all for listening.
So Lee, thanks so much for that. Really interesting. And I guess one of the things that kind of came out in preparing for this episode and during it is that, yeah, whenever Passive House is mentioned in the UK and you guys, it seems that almost everybody has worked with you and has good things to say about you. So nice work from you guys in MBC over the years. One of the things that I've always liked about how you approached your spec or how you build or how you, because I guess as the manufacturer, you don't always decide the spec, so you're really pushing things onto the customers, architects, or the homeowners, and it's the choice about breathability. So a common kind of exterior sheathing board, in most timber frames is to use OSB, And I see that you guys are, absolutely firm on the breathable MDF on the outside. And I guess I know from my own experience that it makes such a, kind of dramatic difference in terms of the eventual moisture capacity or the percentages in the external walls. So it's a huge factor of safety to kind of force into the industry. Not that many people do it, but yeah, we kind of would hope that people would kind of follow on from that. And same kind of thing with the cellulose, it's a natural follow on, and it buffers I suppose the water vapor as well. And that coupled with the variable thickness of the external wall, it's really given kind of huge opportunities to people. And the other kind of thing that you mentioned, Lee, that to me looked kind of sounds interesting and unusual, you're taking responsibility, so kind of offering to take it. And it's kind of the opposite approach to a lot of people and a lot of it is down to the air tightness. So nobody wants that pure responsibility of the 0.6. And, it's cool to see fabricators just taking that one on. Yeah, that's on us. I know you did say it's mostly down to the installation quality. I probably think it has a little bit to do with the tapes and membranes, if you don't mind me saying, but I think generally it's really, really, kind of uplifting to see somebody stand over their work like that. I don't know, Mike or Ben, what you thought on that?
Yeah, I'm always impressed. I deal a lot with people who are building their own houses, and I think that choice of how you're going to build the house is one of the most critical decisions that you make in the whole process, because it locks in the embodied carbon and also the efficiency. And that's what I really like about this. I think it takes away so much risk. It was interesting, I heard that word speed a few times come into it, that they were wanting to get things really moving, which yes, you always want, but it's just interesting to hear it in that context, all the precision that comes into play as well. A couple of aspects that I was wondering about. Firstly, the form of the building. When we come back to Adrian, I know that it had a road coming nearby, but I was quite intrigued as to what the constraints were on that. And also for MBC, are you facilitating the architecture and not really asking too many more questions, or how does that relationship work? But yeah, as a system, thumbs up. I don't know, Mike, what are your thoughts?
Well, yeah, as I said at the beginning, I've got first-hand experience of working with MBC, and it was always a pleasure. I don't just want to sort of, blow smoke up your backsides, but you guys rock. You really care, and I think that from our perspective, in my previous life, delivering these one-off projects, it was always an enormous challenge getting the right team in place. And so, MBC from the top down is populated with people who are honourable and who care about what they do, and that kind of joined upness, taking responsibility for more than just, a shell, and someone else has got to put the thing in the ground that shell goes on, and someone else has got to make it airtight and all the rest of it. You go beyond that and do more, and that's rare and it's commendable. So I just wanted to acknowledge that. I'm really intrigued. Ben's sort of hinted at it in terms of the form. I'm intrigued, to find out from you guys what the challenges were on this project. Particularly when it came to design coordination. Were there any, or was it plain sailing? We perhaps just sort of tease open a little bit of a discussion with you guys now, and from my perspective, get an insight into what was hard about it, what didn't go quite according to plan, what challenges did you have to overcome, how hard was it to get to where you are today? That's a really interesting angle from my perspective. You got any insights to share on that, Lee or Adrian? It'd be great.
From a design point of view, obviously, typically when we get involved with these projects, sorry, Adrian, I'll just take that first if that's okay. Generally, when we get involved with these projects, it's often post-planning, so there's very little influence that you can have on any designs. If it's pre-planned, then we might be able to say, well, generally more from a cost point of view, that actually if you make this this little change here, if you move that wall, then we no longer need that glue lamp beam or that steel. But really post-planning, our hands are tied. Now Adrian's worked with us before, and because of the views and stuff, he would have been, the structure has to meet the requirements of that particular project, because of what the clients were looking to achieve. But I imagine there was in terms of your initial looking at the designs, Adrian, I imagine there was a lot of complexities there.
Yes, yeah, and I think the main thing that came out from it is obviously the entire thing was driven by the view. So they wanted, you know, the first thing they wanted is that every room wanted a view. Well, we know that's not always possible. And if you're in the utility room, do you really need that view? So there was obviously we had to kind of get that right. But it was handy that we had worked with Lee and MBC, and again it was a social housing scheme, so there was nothing. They weren't grandiose. They were fairly standard sort of built form, but it helped us certainly that we then got to understand the system. We say, right, okay, so we can do this with your system in a sense. So it allowed us a little bit of kind of flexibility. And we have worked on other types of passive constructions, but I think it would have ended up being a lot more complex, a lot more steel, a lot more difficult junctions and so forth. So I think we were able to modify the design a little bit to kind of fit the MBC system. So there was, you know, and I mentioned it earlier on, a bit of an iterative process really. You think, well, okay, does that wall need to be there in that particular form and shape? Can we do it slightly differently? So I think that kind of that really helped. So the challenges were really, you know, you've got all that view, all that glass, but you're still going to meet a really kind of high standards. But we were kind of constrained in many ways by planning as well, you know, that we couldn't have, you'll see there's like side wing walls to avoid kind of views over onto neighboring properties. So that sort of kind of started to kind of sort of develop the form of the building really.
What was the planning inspector's view? You said you had to take this to appeal. How difficult was the appeal process, and was there much local opposition, or was it the planners who
there was no local opposition at all? The actual in that particular area, there's been a lot of kind of houses that have developed over the years, and some even kind of larger kind of properties. And we, from an early point, we'd actually done a property on the opposite side of the bay. And because it's in the area of outstanding natural beauty, what they're worried about is it going to change that sort of kind of view? And it's not a view necessarily of standing on the beach looking at the houses. You might be a mile out to sea, you know, on the sand at low tide. And I know we're kind of concerned about that. So we used a firm called Land Studio who do a lot of visual appraisal, landscape appraisal. But the planners weren't convinced. And I think they were just kind of nope, you can't do that. You know, it's got to be a tiny little property or whatever. But when it went to the appeal, the inspector just said, well, no, they've done everything right. And it demonstrates that it kind of fits into the landscape. It's not changing the landscape. So they were just very dismissive of the council. I think they not sort of being sort of, you know, allowing things, you know, it's sort of interesting design, passive design. They weren't sort of even, you know, interested in that aspect of it.
North Wales as well is an area that's got some fantastic scenery and very, very beautiful. But there's also a fair bit of rain. So during that construction, I saw some images there on the time lapse of the windscreen wipers going. How does that affect the system?
Yeah, so in terms of, you know, it's unusual for us to not do a project because of weather. Essentially, if it rains, our teams get wet. That's why I've got an office job. Yeah, but there's some things. So in terms of like pouring concrete, there's times when you might have to delay that. In terms of the wall, it's designed to dry. So obviously, because it arrives on site, there's no insulation on it. If it gets wet, it doesn't really matter. It just dries. And by the time we come back and put the insulation in, you know, the roof's been sealed, the windows are in, it's been made airtight. So the buildings have plenty of time to dry. So the rain isn't really a particular issue in terms of the system. Really, the only time it's cold in terms of the foundation, and wind, because there's just a point where you can't put a panel on a crane.
Lee, just in terms of the kind of full system, I suppose in the UK we see, you know, a lot of open studs, and like Micah touched on, some stick builds on sites. You're selling something pretty different, and I guess it's at a pretty different price point. So I'm wondering, one, how do you I can convince people of that, but two, do people always opt for the full system? You know, do you always do the foundation? Is that always part of it? You know, or what way does that work with clients?
The majority of people, and actually, yeah, one of the reasons why we've grown so much over the last couple of years is because we offer the foundation. We're absolutely amazed more people don't do it, because we won a huge amount of work because we offer both the timber frame and foundations. And even so, we've got our passive house system. We've also got a variety of closed panel 140 stud timber frames, and often people will still take the passive house foundation, even though they might go for one of the sort of lower grade timber frames, just because they like the idea of having one company that does both. But yeah, there's a lot of stick build that goes on. It's just that initial cost to actually open a factory it's a huge amount of money. And the bigger issue in terms of, if you're looking at cost and passive house, I would say it's not necessarily that passive house is expensive. It's that because we're still allowed to build to such a low standard, you can probably build too cheap. And actually what we're finding is that every year passive house becomes a greater proportion of our work, because as the building regulations increase, and obviously they're about to increase, we assume that's going to have a big positive impact on us. The gap between sort of passive house and what you're allowed to get away with narrows. The things like Adrian was referring to, the other project we did previously, social housing. The idea of doing a passive house social housing 4 or 5 years ago, madness.
Yeah.
The fact that project can actually be around, that was with us working with Adrian and the local builder, because the local authority, they just had a real sort of hunger to go further than they needed to.
Yeah, no, thanks. It's really interesting.
I know that Zach has been collating questions for the Q&A from the audience now. So can we hand over to you, Zach, and you can be the concierge for the Q&A session of this episode.
Absolutely, my pleasure. Thank you, Mike. Great discussion, great presentation, and yes, we have lots of questions and a couple of very inquisitive audience members, which is fantastic. But so what I'm going to do is invite folks to ask one question. I know that folks have lots, but I'll be cycling through the names here, so we'll get a chance to get hopefully to everybody. So the first question comes from Gordon Taylor. So Gordon, you want to choose one of your questions and pose it? So Gordon, you'll need to unmute. And okay, great. Fire away. Gordon, sorry, we can't hear you. Oh. I think I will ask your first question, Gordon, because it looks like there may be a technical glitch here. Your first question was, how do you justify the passive house level of insulation for the garage?
That's a good question. Ultimately, with many garages these days, they don't house cars, they house stuff, so I can imagine it may end up being a gym, something else like that. So essentially they wanted all the entire built form insulated up to the passive standard to allow for future kind of adaptation. So that garage is another space. So clearly, if we insulate it now, bring it up to the right standard, it's adaptable. So that's sort of future-proofing in a sense, really.
Excellent, thank you. Okay, so next up is Mick Woolley. Mick, do you want to choose one of your questions?
Hi, Mick Woolley here. I'd like to just get you to comment on what density you blow cellulose to. I mean, you mentioned that you've got a 300 mil wall and then you've perhaps got a 400 mil or more roof section. So for instance, do you blow those to different densities to make sure you don't get slumping?
It's a great question. I don't know the specific density, but I can certainly send you the data sheet which has it. But what we do is once we've put the insulation in, we essentially test various different areas of the building. So there's a tool that you can put into the wall to check the density in the wall or the roof or wherever it may be, and you get a reading on it. And then our client can then check that reading against the manufacturer's guidelines, which basically says that if you achieve that level of density, then something's not an issue. But if you want the specific calculation, if you send me an email, I can send you the document.
Great, thank you, Lee. Thanks, Mick. And we recently had a presentation at our construction tech program at the Passive House Accelerator about dense packed cellulose installation, and it'll come from a North American perspective, but I'll share a link to the video of that as well in case that's helpful. Okay, next up is Stephen Howland. Stephen, are you able to unmute? I see that it looks like you're here. Okay, I'm going to ask your question for you. So has there been a mismatch between an efficient and low carbon building and passive house certification with building regulations? Can you have a fantastically passive house, but the building regulations rating may not be the best?
Yeah, in terms of the...
Oh yeah, sorry, Lee, go on.
Yeah, sorry, no, Adrian, yes, basically. I'll let you tell, Adrian.
Yes, and quite so in this instance, and obviously we're pushing the, as far as we can go in terms of the U values, which is far in excess of the building regs, but you still get a dreadful EPC, which is an energy performance certificate, because it's just a very poor way of measuring the performance of buildings. So I think it still comes out at the moment at a B+ or something, which most people would think you'd be an A star or something, but it's clearly a different way of measuring things, and it's not very clever anyway. So I think we just achieved building regs. We had to do some SAP calcs as well as the PHPP just to get through that particular stage. And the building control officers, to be fair, they said, yeah, we know it's passive, so we're not really worrying about that aspect of it.
Great, thank you. Next is Rory Kennan.
Hi there. Hi.
Larry.
Given that your insulated foundation systems are pretty new to the market, as far as I'm aware, are there issues with the home insurance and mortgage providers? Are they nervous to get involved with your build? Or
it's a good question. So in terms of the timber frame, you don't really run into any issues. But yeah, we're a structural timber association member, so that generally makes that process a lot smoother. You're right. Yeah, the rafts are relatively new to this country. They've been used everywhere else for an awful lot longer. But as long as you avoid sort of someone like an HBC or something where all they want to do is 10 house type A's and really use materials that have been used for a long time. As long as you go to someone that's a bit more bespoke, so we typically recommend a company called Build Zone, then generally you're okay. But it's a good question. You just need to make sure that whichever warranty provider you go to, you make them aware that you are using a raft foundation. But it's less of an issue now than it was, say, 2 or 3 years ago.
Great, thank you.
Excellent, thank you, Rory. So next is we have another question from Gordon. Gordon, I'm going to give you a moment to see if you can speak yourself, and otherwise I'll choose one of your questions. All right, I'm going to choose one of your questions. So the forward wings must lead to shading of the windows. Is this done to limit overheating?
Yes, and our PHPP actually wanted us to even reduce the window sizes, which you can imagine that discussion with the client didn't go down particularly well. So the wings do 2 things, yes. So they are there to obscure the views of neighbouring properties, but they do certainly help with the overshading, and that's why the roofs also carry on across a lot further. This was built into the design early on, knowing that we were going down a particularly passive construction, really.
Excellent. Great, thank you. So Mick, we're up to you. You had a couple other questions. So Mick Woolley, if you'd like to pose one of those.
Oh, sorry, Zach, can you read them? I can't find it just at the moment.
Yeah, yeah, absolutely, sure. Let's see. Oh, actually, one of them was a follow-up to the density. So this is one. How do you try to ensure people actually complete and certify? Surely they are passing up on one of the main QA checks that the build really has done what it should.
Yeah, it's a really good question, but on one way, of course, you want to encourage people to go the certification route, but you also don't want to terrify people of going down a sort of passive house route. Our system has been certified many times. It's a legitimate passive house system. The majority of our customers don't choose to certify. Some of them can't, because whilst they're buying the passive house build system, perhaps the orientation's poor, perhaps the form factor and things that maybe they've got no control over because of the planning requirements in the area just doesn't work in passive house ways. Sometimes, I said earlier, we can make our walls bigger or smaller. There's a point where maybe it becomes a bit, you get 4, 5, 6, 700 mil. At what point do you say, well, actually, maybe on this particular project, we'll try and get as close as we can, but maybe not go the whole hog. So certainly we'll always try and encourage it, because it just makes us look better. But we certainly wouldn't want to scare people off going down the passive standard route.
Any other responses?
No, just from the client's perspective, I think they sort of kind of like the idea of it, but then I think, as Leah said, sometimes they just sort of balk at the last minute and go, oh, all I want is my house. I don't necessarily want all the data, and hey ho.
But it's quite interesting from a sales perspective that if you come to sell that house, if I had the choice between a certified house and one that should be there, I would always go for the certified house, because, and half of it is just, I don't know whether all the data for the house would be available. What sort of checks other than air tightness have anything been done post occupancy just to check on the house?
Well, we've got a good relationship. We've got a good relationship with our customers, and we essentially rely on our customers for new business. So I was visiting a customer that we built 4 years ago yesterday with another customer. And because the overwhelming majority of our work comes from referral, so we in terms of doing positive specific checks, no, not so much, but we stay very, very close, just because we've developed. When you build someone's dream home, I think you develop quite a strong relationship with these people. Some of my customers that we've built houses for, or my customers for the last 10 years, some of them are now my closest friends, and it's because you really do become quite close, building someone's dream house.
I think it's a really valid point, Ben, in terms of what you get with certification or compliance. So, while what the guys are doing is to that, really high standard, the handover file with the passive house is really quite different. And I think that's what you're talking about, isn't it? If someone's buying it, you've got a really significant body of evidence that everything was built. Not that you doubt anything that's done, but it's a much less complicated certification process if it's not passive house.
Should we ask Mike what he did when he used MBC?
What I did in terms of trying to persuade customers to go all the way.
You're throwing it back at the clients.
Well, it's their money, really, so it's driven by them. I did always do my best to persuade people wherever possible to get their project certified, because of the perceived added value, in the future, and just the certainty of it being a measurable standard and something that is rubber stamped by a third-party organization, based on pretty strict criteria. So it was a quality driver for me. Often, however, again, in my old life, people would say, well, actually, I'd rather buy a ride-on mower, or I'd rather go on holiday, or I'd rather do X, Y, or Z, and it got cut. But that, without a doubt, is one of the key things that's informed us at Kiss House. Is we just want to do Passive House certified as standard, and then no one has the choice. It's just what we do, so that's our approach now, is just we do it. And then our strategy is to try to make that as kind of cost neutral, or as low cost, or make the cost invisible and as low as possible, so we can standardize it, hopefully. But yeah, it's ultimately it used to be up to the customer, and now it's up to us.
I tend to agree. I think it sometimes it is the cost of the whole PHP process, which they want to go down, but towards the end they're sort of going, oh, I'm not sure. But I say, if you did integrate it as you're doing now with the actual build, it's all part of a rounded process. You get the build, you get the certification as part of it. I think clients would probably be more willing to kind of go down that route, really. I think when they think it's an added thing, that's when they sort of go, as you say, I've got a kind of Bose hi-fi system that's going to cost me £5,000, or I get my PHPP, so yes.
I think to not try to make too much of a big deal of it either, the more kind of normal, and well, that's just what we do, really. That's how we want to try and frame it now, because it should be just what people do, really.
Well, this is fantastic. We're just going to do a quick pause here, and we're going to wrap up this first hour. Probably some audience members will need to take off after this first hour, which we totally understand. That said, we have more questions and discussion to continue on and bleed into this next hour. So please stay if you're able to. So we're going to wrap up by saying a couple of some thank yous and share a couple of upcoming events. Co-hosts, do you want to start with some last words for the first hour?
Yeah, I'd say just like a huge thanks to Lee and Adrian for being so open with the time and information. You know, it's kind of what the industry is about. So yeah, there's lots that people can take from the good work that you do. So yeah, just a huge thanks for that.
Yeah, and I think I'll carry on by saying, you know, it's a great system. I certainly know lots of people who have gone down the MBC route, and I think we've said a lot in this presentation. So thank you.
Keep up the good work, guys. Thank you.
Awesome. Okay, so please stay tuned here for more questions and answers. I'm going to make some important thank yous to the sponsors who make the work at the Passive House Accelerator possible. So thank you to our founding sponsors, 475 High Performance Building Supply, Bax Ingwe Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stillcorp, and Zola Windows. Thank you also to our champion sponsors, Icon Windows and Doors, Proseco, and SIGA. And thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thanks also to our patron sponsors, Aero Aggregates, Aero Barrier, Brennan Insulation and Air Tightness, Brooklyn Solar Works, Euroline Windows, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. So big thank you to those sponsors. On the Passive House podcast, we have an interview by co-host Matthew Cutler-Welsh, who's based in New Zealand, of Amy Tankard, who is the CEO of Passive House Institute New Zealand. So it's a great glimpse into the Passive House community in New Zealand, as well as some storytelling about Amy Tankard's own Passive House house. And we are consolidating our construction tech programming and our global Passive House showcase programming under the umbrella of Passive House Live moving forward. So we'll have a Passive House Live episode every Wednesday, each Wednesday of each week. On the first one for February, we have a project showcase edition with Ed May, who is a leading practitioner and educator of Passive House consulting based in New York. And he'll be talking about 10 easy ways to ruin your blower door score and remedies. So that happens next Wednesday. We hope you'll join us. And the next Building Performance Interactive episode will be episode 5. It will take place on Thursday, the 24th of February at this same time. And we hope to see all of you there. So thank you. And now let's go into the overtime here with some more questions. So we have Peter Nichols. Let's see if Peter, if you're still here, if you could come online and ask your question, that'd be great. Looks like you are here. I'll give you a couple moments,
Peter's microphone isn't working, so.
Okay, great. I got it. Thank you. Okay, so Peter's question is, what is the maximum height you can go to with this system?
That's really a question for timber frame in general. I mean, they're building like hotels, like multiple stories now in timber frame, Premier Inns and things which go 10+ stories. So that's really that's not specific to this system. That's just as timber frame has got better over the last few years. It's not just 1, 2, 3 story buildings now. You see multi-story hotel. I don't know what the highest one is. I think there was a hotel that was done on the South Coast recently. It was like 12 stories if I remember. But yeah, it's becoming much more common for larger buildings. What's the key thing is you can incorporate whether it's steel or glue into these buildings now to make them stronger. They become kind of like a hybrid system for really big buildings.
Great, thank you. Okay, next up is Keely Harris. Keely, I see that you're there. And you're unmuted, but we can't hear you. So I'll ask your question. Sorry about that, Keely. So the question was, what is the best practice when joining a SIPS roof to ICF walls?
Do you want me to say that?
Yep,
So I can cover a bit of that if it helps. So, obviously we're not ICF or SIPS in terms of build systems, and I think the key tricky thing is what I referred to in my video is that you're crossing systems, so it becomes tricky. So if you've got an ICF wall and say a SIP roof, whose responsibility the junction? I've seen it done many times. There's lots and lots of different ways of doing it. But for me, the key thing is making sure you actually have someone that takes ownership of that junction.
I think we did a ICF house a couple of years ago now, and I had that very same sort of question. It's that kind of junction there, and you end up with this cold triangle because the ICF just stops, and you end up, unfortunately, cutting and fitting insulation to fit into that sort of gap to get the continuity. But it's difficult to get the sort of same values on both elements, whereas obviously if you go with the MB system, it's more, you get more of a continuous kind of U value through that particular junction. It's kind of a little bit untidy, but it can be done.
Great, thank you. So it looks like Rui is next, but I don't see them on the call. So next up would be Ian Small. Ian, are you here?
Yes, I am.
Okay, great.
Thanks for the presentation. Lovely project. Just wondering about the sub-slab insulation. Have you considered a foam-free solution, and have you tried the geocell foamed glass gravel?
For me, it's not something I know a particular great deal of. To be honest with you, we've our system is tried and tested, so we've used it like that for a long way. I know there is progress being made in various different layers of concrete to make sure they're more sustainable and stuff, but no, we haven't tried it, and it's not something I know a huge amount of, to be honest with you.
We've used it only the only time we've used it is on sort of heritage buildings where we want to try and kind of make sure that the whole kind of structure, 17th century barn or whatever, is kind of breathable right throughout. So that's the only time we've actually used it. We've not used it on any kind of timber frame or slab types. Other than that, really.
Okay, thanks.
Great. So Rui is here, but their microphone's not working. So I'll ask the question. How does the fixing work between the timber framing / walls and the concrete slab, as the timber framing is projecting out from the slab edge?
Oh yeah, so that detail it's an interesting detail, and that's where you have the benefit of a twin wall system. So whilst you've got two studs, essentially the structure is on the inner stud. So that's why you see the inner stud that sits on the concrete raft. So it sits on the concrete, and the outer stud that sits on the insulation. So you've got your structural strength on that inner stud, but you can still maintain that continuous insulation where the insulation can sit. The insulation of the wall can sit on the insulation in the raft. Yeah, I should have covered that detail in my presentation.
All good. You just did. So it looks like the next question, the person is not here. Let's see, I need to get the name. But so next up is, yeah, so Richard Coles is not here, but John Garrison, I think that means you're next. If it looks like you are here. So if you could unmute yourself and ask your question, that'd be great. All right, John, I'm going to ask. Okay, no, all good.
Apologies.
Yeah.
Multitasking.
Yep.
Yeah, so I was just curious whether they had any experience using aero barrier and whether or not it was necessary to achieve the desired air tightness for Passive House.
No experience from me.
Nor me, no, sorry.
Oh, I think you guys have been kind of consistent in really not needing it, Lee, through a system process. So I think kind of area barrier is great if you've kind of failed to achieve the 0.6 and it's quite late. It could be useful in that way, but it's not really a common product in the UK.
Yeah, we tend to tick the box.
Great.
Fantastic.
Thank you. So next up is Wayne Robinson. Wayne, are you here? Looks like it.
Hi, yeah. Can you? I don't know whether you can hear him or not, but
yes. Yes.
I was just wondering how you handle the heating and ventilation, because we've, in our experience, some of the houses we've done when we go back and visit them, especially the social housing tenants, they still go along with their old cultural. You know, if it's cold, they'll put a heater on. If it's too hot, they open a window, and instead of waiting for the system to kick in, and consequently, it doesn't quite work out that well. They're mainly due to because they're used to living in a council house, and that's the extent of their knowledge.
It's a really good question, and actually, this came up on our Anglesey social housing project recently. It wasn't really one I thought of. I just thought it's fantastic that social housing, you know, they're doing a passive house project. That's amazing, but didn't really necessarily sort of preempt any of the potential problems. And I think it's an education thing, isn't it? I don't think it's necessarily a product thing. I think it's an education thing. So the first thing that I was asked to do was for all the maintenance operators of that local authority, I did some training for all of them guys, because most of them, it's not just the customers, most of the people working in them houses have never worked on a passive house either. So it's the whole chain has to be educated, and we can't go and speak to every single tenant. But so what we did initially was basically educate the maintenance teams, and then the maintenance teams in turn went to educate the tenants.
Yeah, that's cool.
It was relatively recently finished, but it'd be great to go back there in a year and see how it's gone.
Yeah, they've got a commissioning phase they're going to be doing there, just to sort of go over kind of the processes. They're not an overly complex MVHR system in there, but one of the things they were the reason they were doing it for the social housing was to try and alleviate high rents, put the rents down, and sort of fuel poverty as well. So I think really it's sort of kind of getting them so that they're not wanting their houses ridiculously heated, but also sort of down at the cold end as well, really. So I think they will be guaranteed to have a year of sort of kind of education and running the actual kind of systems really with the tenants.
Good. Yeah. Okay. Thanks. Yeah.
Excellent. Okay. So Stephen Howland, sorry, I skipped over you, assuming that you weren't able to come on, but it sounds like you are. So why don't we get you up for 2 questions, then we'll go to Bernard, and if you have a remaining question or 2, we can do that after that.
Yeah, the first one is, it was mentioned about the concrete foundation. What type of concrete was it? Was it ordinary, or did it contain like GGBS or fly ash for low embedded carbon of it? And the other one is, what's the lowest air tightness you've managed to achieve in a dwelling to date?
Okay, I can answer your question quickly on the concrete. It's a C30 strength concrete, so there was nothing particularly special about it. Again, we were slightly limited on what we could actually get to the site because of the local concrete plant, so we couldn't really go with anything particularly exotic, really.
In terms of the best air tightness, I'm not sure what the actual best. I know, I think I saw them recently, which was 0.18. I would imagine we've done better than that, but the concern for us is we obviously put in our contracts that we're going to pass a 0.6. We're sometimes a bit nervous about advertising the really good results too much, because then they sort of people expect them as standard. But I think the only time I can remember that we actually failed an air test was when the client bought the wrong door. When he put his key in the lock, we passed. So if that, just to explain sort of how airtight we're talking, I'd just like to tell that analogy.
Great, thank you, Lee. Okay, so next up is Bernard.
Good afternoon. Last Friday, I was at the ATTMA with Bill Bordas and Paul Jennings, and we spent the last 18 months developing advanced instrumentation using ultrasonic sound and computer science. So if the building fails the door fan blower test or the pulse test, this technology will help you find where the air leaks are. So if you're interested in knowing more about the Porter-Scanner Airtight 520, do feel free to get hold of me. There's a good write-up on our website because the results came through of our work last Friday and this week, and we published them. Technology goes back to 1987, when it was used and has been used since by the Royal Navy to stop ships from sinking. And it was initially used to identify water ingress in hatches and portholes. And we then now adapted the same technology, added computer science. We can detect, locate, and measure any air leak with a diameter as small as 0.5 millimeter.
If you want to send us the information, I'll be happy. It's nothing to do with me at MBC, but I'll be happy to pass it on to the right people.
Thank you very much indeed. Yeah, it's very kind. I'll do that. Thank you.
Yeah, super interesting. Thanks, Bernard. Okay, so next up is Gordon. Sorry, Gordon, I missed you. Are you available to unmute and ask your question? If not, I will ask the question on your behalf. So that you asked, timber construction can lead to shrinkage over time. Does this cause problems with air tightness or heat leakage, or with finishes such as rendering, tiling, or brick veneer?
It's allowed for.
Could be me that.
Yeah.
Sorry, go on, Lee.
I was going to say it's allowed for within the engineering. You could cover the tapes, I guess.
Yeah, I think generally it's quite a solid system you're using, but exactly, yeah, the tapes allow for movement, so they can stretch and the adhesive can slide. They're tested with PHI with that type of board already, so yeah, with some stresses and things like that. So it's generally built into the system.
In terms of the render board, that's once you got the engineering, you'd work out in terms of air gaps and things like that, so that you can allow for any movement over time.
Great, thank you. So Stephen, if you have more questions you'd like to pose, you have the floor.
Yeah, just one final one. The wall U value and the roof U value, what's the lowest they can go? Or is it easy to say in the future, if in 5 years, 10 years down the time you want to retrofit it to reduce the U values further?
Stephen, it was a little hard to hear, but you also, no, it's okay. I think you asked what is the lowest U value you can go with the wall and roof timber frame system, and how easy could it be to improve insulation and reduce the U value in the future?
Yeah, correct.
Yeah.
Yeah, so it's obviously the key thing with our timber frame system is that you just make the wall bigger. So if you've got a timber and a connector, you just make the connector bigger, and you can put more insulation in. So we regularly go to say a 400, which is a 0.89 U value. There's no reason why you couldn't go beyond that. It really then becomes an issue of wall size, and obviously, we've already got some of the smallest houses in the world in England. So that wall size can be quite critical in terms of maximizing your internal floor area. So in terms of U value, you can really go as far as you need to just by making the wall bigger. But there's just a point where for a lot of people it becomes not feasible.
Great, thank you. Well, I think that wraps up our questions and answers here. So I think it's time for us to close things up. I want to give a big thank you to Lee and Adrian for this inspiring project and for this great presentation. Thank you. Also, thank you to our co-hosts, Mike, Ben, and Hugh. for the conversation and for your guidance today. And also a thank you to Hugh and Yulia for creating the BPI series in the first place. We hope to see you again soon. We're going to be returning for episode 5 on February 24th. And until then, be well and do good work out there. We'll talk soon.